Hi everyone, thanks for joining us today. It's great to have you all here. I have with me AJ Park. I think he was already introduced by Jackson, but I would love to go into your story first. Like, who is AJ Park? What has been your journey like? Just for the audience to know.
Thanks for having me. AJ, founder of Radius. I was the software engineer for Samsung Research for 14 years. At the time, I specialized in security and privacy. And then the first project that I did related to blockchain was the blockchain-based marketplace for personal data on mobile in 2016. It was the in-house venture project at Samsung. So we always thought thinking of something like how to monetize your personal data on mobile, because that's really valuable from the Samsung's approach. So at that time, I thought that our blockchain can be used to monetize this data without any intermediary. So right now you are giving your valuable data to almost for free in exchange for using any internet services. So anyway, that's the first project that I did for blockchain. And then I thought that ZK would be the key component for blockchain space. And then also we found the MEV was a really big problem. So I teamed up with developers and researchers from the financial and ZK space to solve this MEV problem. And then in 2020, I received our Ethereum Foundation grant to build MEV resistant AMM, and then we went for much a bigger problem, which is the centralized sequences for rollups. So that's how I ended up here.
Awesome. That's great to know. I would like to just go into a bit more about what Radius is. I mean, I know in the audience probably all of them already know about Radius, but if you had to explain someone who is just coming in, just knowing about blockchains, if you had to explain to them what Radius does and what is this sequencing problem, the pre-confirmation problem, or just in general the space of the problems in which you are playing around with, what would that be? When you explain what Radius is in some simple terms for the audience.
So Radius is building various types of sequencing, such as decentralized sequencing, based sequencing, and shared sequencing, to help rollups sustain in economical way. The reason why I mentioned the economic sustainability for rollups is that because that's a really important issue for rollups. Like for example, let's imagine that you are going to build a dApps based on smart contracts. The only thing you need to do is just deploy smart contract on base layer. And then the base layer will take care of the rest. But if you are using the rollups to build your dApps, there's one thing that you need to consider how to solve that, which is the running sequencer nodes. That's the place that a lot of operational cost happens. So you need to come up with some kind of a robust revenue source that to cover these costs. So that's why actually the area that Radius is focusing at this moment with a bunch of sequencing mechanism. For example, there's two ways to cover this cost. One is that enhance the existing, the current business models that the most rollups have right now. Another one is to find additional revenue source that other than the current one. The first one, the existing rollups revenue is come from the end users transaction fees. So we want to make this to enhance this business model to provide decentralized sequencing, such as that centralized sequencing is great, but there are a couple of problems. Which is one is that liveness. You don't know when this centralized sequencer is going to stop or not. Another one is that it's centralized, so these centralized sequencers can do anything without notifying you guys. So such as censorship or harmful MEV stuff. So if these kind of events or attacks to users happens, users are not gonna use your system anymore. So that's why we focused on the decentralized sequences first to enhance the current business model. Another one is that finding the additional revenue source, such as that if we provide, a block space that rollups have is really the most valuable assets in blockchain space. So we'd like to combine multiple rollups block space to generate additional revenue source. So that's why right now we are focusing on shared sequencing to connect multiple rollups, and also based sequencing to connect rollups and Ethereum. So that's what Radius is doing. I mean, it's a bit long, but yeah, that's short.
No, thanks. I think that sets the context for a various number of topics that we are going to discuss today. I think one of the points that you discussed is additional revenue, and you discussed MEV quite a lot, and the role of centralized sequencers at the mempool level. I think if you can go in a little bit more, because apparently it seems to me that if I was building something like that, I have the entire mempool by myself. What does decentralization stop at that point? But I think one of the things that Radius I like a lot about it is that of the encrypted mempool, right? So it's just not about monetizing the data that you talked about in Samsung days, right? It's not about taking that mempool data and just monetizing on top of it because you have the ability to capture MEV. I think it goes beyond, and where you are trying to give privacy, you are trying to have ordering and over-encrypted data and over-encrypted transactions. So if you can talk a little bit on the encrypted mempool side of things and say why that is important, I think that would be very helpful.
Actually, this encrypted mempool thing is the first core features that our team have developed in 2020. Encrypted mempool is not like something that keeping transactions encrypted forever. It's more like a commit reveal scheme that these transactions remain encrypted. So for a specific time period. When you think of some kind of attacks to users like a censorship or harmful MEV stuff like a sandwich attack or front-running stuff, because your transactions are open and in plain text, anyone can see your transactions. That's why the censoring and harmful MEV stuff happens. So the basic idea is just to encrypt those transactions, so anyone, including sequencers, cannot see your transactions while confirming the order of the transactions. So after confirming the order of transactions, we set up our delay encryption to decrypt those transactions automatically after the sequencer issues the pre-confirmation. It's kind of order commitment saying that your transactions will be included in a specific index of next block. So that's how we prevent this censorship and harmful MEV stuff can be protected on the user side. So, and then, as I said before, it's really crucial for users to use your system because it's more like a robust and more, it's kind of protection mechanism that for user side. So that's why we implemented this encrypted mempool.
No, that makes sense. I think if you look at the encrypted mempool level, which protects the privacy of transactions and also just to protect the ordering engine, and then you talk about also things like shared sequencing. Can you expand a little bit more on the shared sequencing aspect? Because till now we have only discussed about, sequencing engine, about protecting the privacy of the users, about MEV. But what does shared sequencing mean, and what avenues does it open up? Like in the shared sequencing space, why is that such a well debated topic at this point, and what are the benefits of that?
Okay, let me explain what's difference between asynchronous composability and synchronous composability with the example of burn and mint transition. Asynchronous composability happens when burn transactions is confirmed on rollup A, and then this proof about this execution on rollup A can be is delivered to rollup B. So rollup B verify this proof and then generate the mint transactions. So it happens sequentially. So most internet services actually based on the asynchronous composability. It works. So, but this synchronous composability works differently. So, it was like there was one shared sequences to build blocks for multiple rollups at the same time. The reason why this synchronous composability is needed while the most internet services is actually based on asynchronous composability, because there are some specific transactions that if the value that these transactions aims to handle changes over time, the time is really important. So it should be like there should be a robust guarantee that these type of transactions is going to be included in multiple rollups at the same time. So such as arbitrage or most DeFi use cases are really important. So that's So that's what synchronous composability is. And then some challenges actually happened. Radius actually, at the beginning of our project, we used shared sequencing layer when we describe our project, but it kind of led to misconception. Sometimes, rollups usually want to have a full control of sequencing for their block space, but they think shared sequencing concept is kind of take control out of from them. So that's why it's kind of difficult for them to obtain our shared sequencing solutions. So, but it's not true. We are not like take any profit from these rollups or any control from these sequences. But anyway, so I think asynchronous composability is really essential to improve this user experience, such as for example, traders or any other searchers. It's real combining these two rollup space synchronously generates much more unique user scenarios, such as cross rollup MEV, cross domain MEV stuff. So that's why we are focusing on this synchronous composability.
Great. I think that should cover a lot of different ideas which might have been questions for many of us. We have, talked a lot about asynchronous composability and synchronous composability till now. And, people have seen that we have announced with Avail Nexus, Radius is now going to work on different parts of the stack and how we together can give much greater control on user level composability. If you can talk a little bit on that, about how these services are complementary, because I think I was discussing with some of them right now, and we have been talking okay, but what does it mean? What will Radius exactly do? What is the role of Avail in all of this? Is it just about DA? Is it about Nexus? Is it about shared sequencing? Is it about pre-confirmations? Is it only about base rollups and such? So if you can describe that a little bit more, I think it will be helpful.
Okay, basically, Avail Nexus provides the cryptographic proof of inclusion for this shared sequencing and synchronous composability that Radius is building on top of the Avail Nexus. There is some kind of there are many entities involved when it comes to the synchronous composability thing. First, shared sequencer. Shared sequencer actually guarantee that multiple transactions for multiple rollups are actually going to be included in each blocks for multiple rollups. That's one promise. Another one is that sequencers are going to execute blocks as they've received from shared sequencers. So those two promises that we need to verify or prove in either crypto economic way or crypto proof way, cryptographic way. So crypto economic way is kind of easy, but in that case, like shared sequences needs to deposit as a collateral somehow, but it's not like that robust, I suppose. So that's why we decided to collaborate with Avail Nexus to get some cryptographic proof of inclusion or guarantee that these shared sequences or sequences needs to keep as a promise. So that's how we integrate with Avail Nexus.
But you talked about guarantees that the Radius team wants and what Avail provides and all that. But as a user, when I'm using some service like Radius, will I interact directly with Radius? Will my user experience change? Is my trust model changing? Is there a greater reliance on someone like Radius to take my transaction and do the correct job? Or for me, it is going to be very seamless, just changing RPC or not even doing that. How is that going to play out? How are user level experiences going to change or not change with Radius?
Okay, so we'd like to keep the user experience as it is, without like whether or not it's to do with the Radius or any other the existing models. So that's why actually the focus that Radius is doing, because like we'd like to have these rollups to receive transactions from user side, and then that's how the user experience remained the same as before. So from user's perspective, there is no difference that these rollups are going to use Radius or not. The synchronous composability or any other coordination between sequences or shared sequences is going to be hidden from the user's perspective. So yeah, that's actually we are kind of building user focus sequencing thing. So users first. So yeah, so
that makes sense. I think let's go on to the topic of proposer builder separation. I think PBS is one of the more heavily discussed topics around the Ethereum community right now, and you guys are of course part of that entire conversation. If you can talk a little bit about what proposer builder separation brings in and how Radius fits into that model. And then after that, we can quickly discuss some of the trust assumptions and the reliance on different entities in the PBS kind of a model. But where does Radius fit in the PBS world?
So actually, Radius is trying to bring this PBS style into rollup space, because PBS is kind of the architecture that brings some kind of robust or sustainable revenue for, at this moment, proposals on layer 1. So, but this kind of this PBS style is the one of the how to decentralize a network. But decentralization on layer 1 is on decentralization on rollup is really different from the decentralization on layer 1 rollups and layer 1, because of the reason why we came up with rollups idea at the first place. Like scalability should be first. So there should be no compromise to scalability when decentralizing sequences for rollups. So that's why we are kind of using some kind of a centralized way to bring scalability for rollups while decentralizing the sequences for the user side. So that's why actually we're using encrypted mempool. So centralization is kind of good for better user experience, but we need to come up with some kind of way to mitigate this centralized power. So that's how encrypted mempool actually is used to mitigate this centralized right to building blocks. So there's no malicious behavior can happen on sequencer side, while we can provide really high performance for rollups when building blocks for them. So that's how we Radius is thinking of this decentralizing rollups. this time. So, and then PBS is kind of the to do with our revenue model. So we also thinking of some kind of some block space network to connecting these someone like searchers or builders who wants to buy block space from rollups to rollups who wants to sell block space to for much more high profits. So that's why we what Radius is doing at this moment.
That is great. I want to ask a very loaded question this time, right? I mean, we are towards the end. See, there are many discussions around modularity, around pre-confirmations, around shared sequencing and such. I want to understand, like, what is the difference, or what is the difference of Radius from other solutions in the space? And then, is there any, like, there have been discussions about revenue, there are discussions about, decentralized sequencers and such. There have been, multiple different entities which are coming into the space. Builders, searchers in the modular stack, and then with each one of those rollups, there might be different levels of searchers and such. So how does all of these ideas come together? Like, what is the end state is going to look like? Forgetting the limitations of the protocol level right now, but what is the end goal going to look like with all these different pieces of the puzzle that we keep talking about across the modular ecosystem space?
Okay. So first, I'd like to talk about the based sequencing thing. Some people say that based sequencing is needed to generate much more higher profits because we can connect Ethereum and rollups. But we think we are thinking of this based sequencing for user safety, such as when you generate transitions on rollup side, these transitions should be included in Ethereum for finality, but there's no guarantee that happens without the based sequencing thing. So if we successfully implement this based sequencing, rollups can give users much more robust safety when they issue the pre-confirmation thing. So that's one aspect that Radius actually viewing this based sequencing stuff. And then,
just in general, how the space is going to look like in, let's say, 2 years' time, lots of rollups, lots of different searchers, builders, everything will be like decentralized, or is it going to be all shared sequencers talking to each other, or one giant monolithic shared sequencer, Radius out there? How is the space going to look like in your ideal world? Okay,
so basically we think that there are millions of rollups. So I don't think one shared sequencer is going to take a sort of a winner takes all. There will be a multiple shared sequencers or multiple marketplace or block space network, those kind of things to help these rollups to sustain economically. So, and then from Radius perspective, I think probably what makes Radius different from others that we actually put end users for rollups at first. So it's really super important to keep this user experience seamlessly and better than anywhere, such as there should be no censorship or harmful MME stuff, while these we need to come up with a way to optimize these, how to sell this block space from this rollup perspective to generate much more high profits. So that's actually, I think that it's going to happen in near way.
Thanks a lot. I think this ends my lines of question to you. Any closing statements that you would like to make?
Yeah, sure. Since we have a strategic partnership with Avail, and then we actually just started onboarding rollups. So if you plan to build any dApps and any projects based on rollups, just to come to us, we can discuss it. We can provide a decentralized, shared, and then based the sequencing stuff. And then, so come to us. We have a booth over there. So let's discuss how to integrate those kind of things.
Thanks a lot, AJ. I would really recommend everyone to go and talk to him. Thanks a lot.
Thank you.